Good afternoon, everybody. Possibly good morning, depending on where you're checking in from. Welcome to the one of the Micromatic Dispense Institute presentations. We're going to talk about possibly what the current state of maybe your draft system is and how to reopen it properly if it's been in the mothballs or hibernation for a while. So just want to say thanks for taking some time today, and hopefully you'll find some value in this presentation. My name is David Greene. I'm one of the Micromatic draft trainers here. I've been with Micromatic since 2001, started in a sales capacity, and been on the training side since 2006 as a course instructor. We do all kinds of training classes here, everything related to draft and other beverages today with that. So any questions or comments you might have during the presentation, please select the chat feature at the top right corner of the screen, and we'll try to answer them at the end of this presentation. With restrictions being lifted or relaxed in many areas, states, counties, want to talk about bringing these draft systems back online. Not only that the systems are performing properly, but the products that we're dispensing that you're going to be serving are as good as they can be, so customers keep coming back. Obviously, they've been away a long time. We want to make sure that they get a good quality draft beer to keep them coming back when it's safe to do so. Just the objectives here, based on how the system was shut down. Was it shut down? Was it just left as is? Heard a lot of different stories in the last 8 weeks about what's going on out there in the draft world, and some good stories, some not so good. But we want to determine what's going on out there, what might need to be done. Maybe we need to do some heavy lifting. Maybe it's just some tender TLC that we need to get these systems back up and going. So we're going to talk about the existing parts and pieces you might have, whether that be some of the hardware or the pressure, the gas components, the beer side of the things, and then also line cleaning. A very good chance that these lines maybe need to be cleaned for sure before we dispense any beer. So we want to make sure we'll go over the best practices with that. And again, any questions we'll have at the end. If you feel like you have a question, please do that. We're going to target about 30 minutes, including the questions for this presentation. So we won't keep too much of your time, but maybe a quick note then, if you're opening back up, ideally we'd want to allow a few days before reopening if possible to analyze the system, take care of anything that needs attention. I got a feeling a lot of people are going to want to open up at the same time, and maybe that's going to be an issue. We also determine what type of system that we're actually even dealing with. Is it a direct draw like a kegerator setup? Maybe a direct draw type shanks through the wall. Could be a long draw, remote system, air cooled, glycol cooled, as well as what type of pressure systems that we're using, and is that up and ready to go here. If you're not sure about any of these parts or pieces or components, ask for help. You can call us, Micromatic, for sure if needed. But we want to make sure that if you're not comfortable, that we do get a trained a technician to be able to do some of this stuff as well too. So what's going on right now? The existing systems. Do you have beer? Do you have draft beer? Is it dated, outdated, expired? Draft beer, most of the draft beer is not pasteurized, so it does have a limited shelf life. There are some breweries, several breweries, that have extended the shelf lives with that. So I would definitely check with your suppliers on that. They're going to know more with that as well. If we have beer, do we have enough beer? Maybe I have 10 or 20 beers on tap. I might not have enough beer for all of that. You could open up just halfway. Maybe that the volume would dictate that as well too. So we could open up, with half of the beers pouring. These are things that can be done. And then the beer that you have, is it sellable? If that first experience is not good, people are going to be clamoring to get out there. But again, I would talk to your suppliers on that. A lot of those do have sensory training, the sales reps, and possibly they can help you out if that is going to be a sellable product. The system itself, was the refrigeration left on? Was it off? Was it adjusted? Heard, again, a lot of stories over the last 8 weeks or so about walk-in coolers just being shut down or just left alone, or whatever the case may be. So if that was shut down, there can be significant off flavors and taste as well too. So the keg storage area, were those kegs, if you have some remaining beer, were they kept cold this whole time? Very important that if you have new beer, obviously we want to make sure that it's cold and ready to go to do that. A lot of long draw glycol systems out there. Several recommendations when these shutdown hibernation procedures were designed. People wanted to turn the power pack off completely. Some people left it on. Some people left it on at a higher temperature though, so it wouldn't use as much electricity. We need to make sure that these are all adjusted back, turned on to be able to do that. This would be a great time. Glycol is a liquid that does wear out, it breaks down, so this would be a great time to change that. It might need it anyways to do that. Get some good glycol in there. That glycol system is the heart of your draft beer system if it is a glycol system, so we need that glycol to be working and properly as well. Easy way to check that out, if you're turn the system on, if you feel the faucets out at the beer tower, if they're cold, more than likely that glycol is working as well. We do want to make sure the temperatures are in the 29 to 32 or so Fahrenheit degree range. They do have pumps and motors. These are working pumps and motors that they run 24/7. If they've been shut down, are they going to turn back on to do that? We want to make sure that glycol is circulating properly. Was beer left in the line the whole times? Was chemical left in the lines? We again heard many stories out there. People have left water this whole time. Not the best idea. Were the beer lines cleaned prior to the shutdown? We heard some people did, some people did not. And I talked to a brewer this morning, as a matter of fact, that has been cleaning his lines every 2 weeks, even though he hasn't sold a drop of beer. That's ideally what we would want to be done, but we want to make sure that the beer in there is good to do that. So just a note, the photo that you're seeing there, this was a cooler that was not shut down. So if it can be that bad when it's working, imagine how it was if the cooler was shut down. We want to be able to do that. Is it worthwhile to clean something like this up, or is it time for some replacement parts, possibly a whole new beer system? Just up to you to decide that. CO2 alarms, we want to check them. If you have a CO2 alarm, these are becoming quite popular out there. If it was dismantled, we want to make sure that that's plugged back in and get back to a working order, get it turned back on. If there are any alarms that go off when you do this, let's heed those warnings to do that. Gas can build up in the walk-in cooler, and this can be very dangerous. So if there is no gas alarms, we want to make sure. There could have been leaks this whole time going on, so we want to leave that cooler door open before entering if it's been buttoned up for quite some time. We want to make sure that we're safe to get in there and work and clean these systems up as well too. The gas source, what are you using? Could be a bulk tank, like the big silver tank pictured in the middle of the photos there. We could have a gas blender, we could have a nitrogen generator, or simply a CO2 or gas cylinder as well. So we want to make sure that they're ready to go and have enough pressure in them. Gas could have leaked out, it could have been low before we left, so we want to make sure we have enough gas. No gas means no beer when we get fired back up. Could have a gas blender, the black box pictured on the upper right-hand thing with that. That's a blender that actually mixes a couple of gases together. So we need to have two gases. When we have a gas blender, we have CO2 and nitrogen. So that would be two gas sources that we would need to check to see that we had enough pressure, enough gas to get what we need to be able to do that. Possibly a nitrogen generator, some folks may or may not have. This is a machine that harvests nitrogen out of the air. They may have been unplugged, so we need to make sure that that's up and running again, and they usually have a backup tank that would take a while to fill it up. So let's make sure we have enough time for that to work. And then if we had any leaks, we want to try to detect them and repair any gas leaks that we might have. Again, gas can be dangerous to us, so if you're not comfortable doing these procedures, you can contact your suppliers or your draft tech or whoever might do some of your normal work there for you. Pressure system components, the other parts of that, secondary regulators. These are gauges that you're mostly going to find inside of a walk-in cooler. Excuse me. I could be using 100% CO2 or some mixed gases as well. These gauges, hopefully they haven't even been touched. If they were right before you put the system in mothballs, then they should be right now. But we want to make sure that they are adjusted properly based on the system's balance. Again, if they weren't touched, they might be ready to go to do that. Beer pumps, another part of the pressure system. Are they on? Do they need to be adjusted? Again, if they weren't touched, they probably should be at the right PSIs to where they were prior shutdown. We want to make sure that any pressure is exhausted outside of the cooler as well. If they did have a flow reversal valve, that's the kind of piece you can see moving around there. That's for dispense cleaning, and we want to make sure they're in the right dispense would be for pouring beer, and there's a flow reversal for the cleaning side of things. We want to make sure once we're ready to go that they are in dispense mode. Hopefully, this is not what the couplers look like. But if the system was shut down properly and the couplers were cleaned and stored properly, they should be good to go. Just inspect them. Sometimes equipment, couplers, faucets, that even if they're clean and they've sat a while, they can get a little tight. So you want to make sure we can do that. So, how were these couplers stored? Were they cleaned and stored? Were they left on the kegs with the pressure on? If so, we could have had gas leaks. If that keg has been tapped the whole time, the gas certainly could have leaked out through some of the tubing, but left on the handle, and if the handle is lifted, the carbonation should still be okay. If you have trouble taking it off or putting the handle in the up or down position, we might want to remove, disassemble, and clean that, okay? They're difficult to take off. This would be a great time to inspect and replace any worn out O-rings, washers, seals to do that. There are a couple of O-rings circled on the right side of the page there that when we are doing a clean breakdown of these, we would want to lightly lubricate them with a probe, a food grade lube that is used. So we want to make sure that they're good in good shape. If a system was, if your system was shut down and your faucets were cleaned, you shouldn't have to do much really to get them ready. But like I said before, even clean faucets that haven't been used for a while can be hard to crack open here. So water is always one of our best friends for any part of the cleaning process. Hot water, warm water poured over them is usually enough to get them up and functioning properly as well. If they weren't, we would want to definitely then remove the faucets, disassemble them 100%, completely clean them to be able to do that. So if the faucets were left on and not clean, they may be hard to take off. So keep that in mind. We want to make sure, and then again, water is our best friend to help loosen any sticky, stuck faucet. If we have any nitro faucet, we want to make sure that the spout, the restrictor plate, are clean and ready to go as well. If we have fobs, we want to make sure that they're in good position. These are clear for a reason, you know, so we can see what's going on. These are a little window sometimes into the beer world. Hopefully they'll be as clean as that one looks there, but I want to make sure that they are. If not, they need to be disassembled, removed, hand kicked apart, hand cleaned to be able to do that. I've seen fobs that were just so far gone that maybe a replacement was in order to do that. I did have a couple of stories recently of some techs not having time to do that. They actually just cut the lines and splice them together to bypass them for the initial opening, and then once time allows, we can get a new one or get this one cleaned up as well too. O-rings that need to be replaced as well too. So then we want to make sure that when we are filling, we want to vent and fill these to assure the correct mode. There's a little lever that's pointing in the upward with a red line around it. That's in the wrong mode. That's the cleaning mode. So that would want to be down once we're full of beer and ready to go for dispensing. The fob vent, the drain line, these are all things that can give us fits as well too. They can get clogged, either stick open, or the vent drain line could get clogged as well too. So I want to make sure all those are freely flowing, and we're not going to have anything with that to do that. So very important to be able to do that. They wonderful pieces of device. They can save quite a bit of money, but they have to be working properly. How about the beer line? Sometimes on a short draw, direct draw, a jumper line, it might actually even make more sense to just change them. A lot of vinyl tubing out there in the world, and that it should be changed every year or so to be able to do that. It's a porous material, so this might be a great time to do that. It might even be easier to just replace it than to clean all these things out as well too. Older vinyl lines can be very difficult to clean if you can ever even get them clean. So we want to be able to do that. We may even want to consider upgrading to some of the new tubing out there. We have what's called an extra flex master. It has the flexibility that we want with vinyl, but it's a much better material than vinyl, not near as porous to be able to do that. So it should last a bit longer. The drip trays themselves, we want to make sure we clean the grate and the grids here. Hopefully no beer was left in it all this time, so I want to make sure that there's no growth or anything, and we can pour some chemical or some drain cleaner down the drain. Hot water is good as well too, to be able to do that. If I have a glass rinser, I want to make sure that that's working properly, that the water's turned on. I did hear a story of somebody turning off the glass rinser, the water to it, so we want to make sure that's on and no leaks to be able to do that with that. And then lastly, glassware. That glassware, I got a feeling, has been sitting around for quite a while. We want to make sure it's all clean and sanitized and ready to go. So now we got the beer in, we're ready to go possibly, but we want to talk about system cleaning. Obviously, beer lines need to be cleaned every 14 days anyways. If they haven't been done during any extended shutdown here, we want to make sure that that is done. Very important to do that. So depending on who's cleaning the lines, could be a beer distributor, could be an independent line cleaner, or even a retailer themselves. We want to make sure, number one, that we know what we're doing, and then safety first with that. We use some pretty strong chemicals that need to be used to be able to do this. So safety, safety, safety. So at a minimum, PPE, everybody's heard a million times recently about that, personal protective equipment. At a minimum, glasses and gloves. I see people wearing face shields, aprons, anything this chemical can hurt us. We want to make sure anytime we're mixing that the chemical is going to be mixed to the water, not the reverse. You can have a chance of that chemical splashing up on you or someone else. We want to rinse with fresh water, never beer. A lot of stories about people rinsing with beer, not a good idea to be able to do that. We want to rinse with water, and then we can actually utilize some pH paper or a pH meter for verification. We're going to test to see if once the chemical's gone, so we know safety first with that. Always a good idea to keep an eye out where that chemical is. Once you're done, I want to manage that location. Once I've used what I need, I want to cap that chemical, and when not in use, put it down on the floor or in a bucket is what I usually like to do as well. We want to prevent chemical sprays or releases, inspect any worn fittings and defective connections. Again, whether tubes have been sitting around a while or even our cleaning materials, some of those tubes do get wore out, they break down, clamps can get bad, and we are using some pressures sources here, so we want to make sure that we keep everything in good working order. And also have available and follow any safety data sheets with that. We want to make sure they're usually required by law. If you have that chemical, you're supposed to have these sheets. The principles of cleaning, as I mentioned earlier, industry standard is 14 days, minimum 14 days. We want to follow the best practices here. So ideally, if it hasn't been done in 14 days, we still need to do it. And then every 14 days here on out, we want to get all that beer that's in that system out with water. Usually we use water. We're going to use a 3% caustic solution, a chemical solution. Follow the directions on that, but we want to make sure the water is somewhere between about 80 and 110 degrees Fahrenheit to be able to do that. Kind of the rule of thumb on that is if it's too hot to put your hand in the bucket of water, it's too hot to do that. So we want to make sure that the chemical has enough time, 15 minutes at a minimum, to be in the system. That 15 minutes doesn't start when the tech walks in the door. That's how long the chemical needs to be in the draft beer system. If we are using what's called a static or a pot soaking, 20 minutes minimum that the chemical needs to be in there. This chemical's not moving, so it needs more time to work here. So this static method is really not recommended on long draw systems. During the cleaning procedure, all faucets need to be taken off. The faucet's really the dirtiest part of the whole draft beer system, so they need to be disassembled, brush clean. Great time to see if all the O-rings and washers are in good shape as well too, to do that. We're going to flush the chemical solution once we're done with cold water, and we're going to make sure again that we're pH neutral at the end with that pH paper. Ideally quarterly, 4 times a year, we're going to clean the system with an acid cleaning solution in addition to the caustic cleaning solution. So we want to be able to do that. And then documentation. Some people require that, some don't, but I always want to keep proper records on what we're doing here. So on the right side of the page there, the principles for proper line cleaning. These are the 4 principles that need to be done. So it's contact time, the temperature of the solution, the concentration, and then the agitation. So all 4 of these are critical to cleaning the beer line. So if we skimp on one of these, one of the other ones need to be bumped up to account for that. So ideally, we want to have the right amount of chemical at the right temperature, agitation with the cleaning pump, and enough time for the chemical to do what it needs to do. So what are the beer spoilers? What are we talking about? What are we cleaning for? So there's things in beer, in draft beer. So there's bacteria. The thing about this, some of these sound pretty bad, but they're not harmful to us, right? They're not harmful, but it certainly can impact the taste, the smell, the appearance. If you've ever had a beer that you didn't even drink and you got to your nose and you got a whiff of something that wasn't, it's one of these bacteria is more than likely the culprit for doing that. So the idea is we don't allow them to build up enough to have these off flavors, off tastes, or even appearances as well too. So my favorites here, Lactobacillus, Pectinatus, Pediococcus, Acetobacter. All of these sound pretty gnarly, I know, but they can all do different things as well too. So if you ever had the sour beer that wasn't supposed to be sour, Lactobacillus can be a culprit for that. Pectinatus is kind of a rotten egg, maybe even sulfur, light a match, car exhaust as well. Pediococcus is popcorn, butter. A lot of people refer to that as diacetyl as well too, to do that. And then the Acetobacter is another one that has some souring, and that can actually take a beer that's sort of clear, if you will, and discolor it as well too. So we want to get after these things, dissolve them, remove them, and get them out of the lines. Yeast, obviously no yeast, no beer. So we need yeast, but yeast will fall out of solution and lay down on the beer line. So we want to make sure that's getting out of there, because once that gets laid down, everything else can lay on it, and that's how beer lines get dirty, is when stuff can stick to them as well too. So we want to make sure we remove that before it gets a chance to build up. Mold is generally an external thing. Mold has to have air to grow, so that's where it's going to be in the coolers, at that coupler, possibly at the faucets as well too. So ideally we want to wash those couplers down, scrub those couplers and faucets, any beer lines in the walk-in cooler. Every time there's a beer bath, mold and doesn't get cleaned up, mold can grow on the beer lines in the cooler. It can be quite funky looking as well too. And then the last thing would be what we call beer stone. And this is a calcium deposit, and that's why we would use an acid 4 times a year to try to help and remove some of that. So these are the things that we're going after to be able to do. The chemicals, the most common chemicals that we use, this is what the breweries use, so that's what we need to use as well too. So these are usually referred to as either caustic or an alkaline chemical here. So sodium hydroxide is the most widely used caustic out there, also known as caustic soda. We're going to use a 3% of mix with this. So for every gallon of water we use, 3% of that will be of a caustic nature to do that. There are other chemicals out there. Some of them are not as effective, but we want to make sure we use the right amount and follow the directions here. The phosphoric acid, as I mentioned, we do need to do this 4 times a year when we're going to do a clean to get the beer stones and some of these other stones that we need to get out of there. We're going to use that at a rate of 2% of caustic when it's time to do that. Basically, there's 2 cleaning methods here. We either have a pressurized or what's referred to as a static soak container, fine for direct draw type system, real short draw systems as well. That can be sort of this stainless steel can you see there. It could be the plastic jug. These are all very common. It scares the heck out of me, but I see a lot of breweries actually filling kegs with their chemical and then going out and cleaning with that. I'm always assuming that that keg is going to get mixed up somehow as well too. But these are the way these soak methods can be done. Recirculation, though, with what we call a recirculation electric cleaning pump. This is the best practice for all systems as well, because we're getting that scrub factor. So kind of quickly, we'll go through this here. Recirculating the line cleaning. It's a 3-step process that we're going to do. Number 1, we need to get the existing beer out. I hate to say it, but that does need to go down the drain to do that. So we're going to hook up everything that needs to be hooked up. We're going to establish an order, so we go back and forth, an X number of lines to be able to do that. So make sure all of our connections and what our pump can handle as well. Once we get going, we're going to just push in warm water to get going, get all of that beer out of there, get all of that beer out of the lines to be able to do that. Second step is now I'm going to mix up my chemical either in a sink or a bucket. Be careful about bar sinks. They need to be clean as well too. We're trying to get stuff out of here, not put stuff in. So we want to make sure we use the right amount of chemical, and to do that, mix the chemical properly, and then since everything is still hooked up, we're going to now start recirculating this chemical solution water mix through the system to be able to do that. Now we're going to allow that chemical to circulate for at minimum 15 minutes. Some longer runs might even take longer than that, but you can certainly go for longer than 15, but at 15 is the minimum. Once that 15 minutes is up or so, we're going to turn it off, and then now we're going to get rid of any chemical that we have in the bucket or the drain. Good idea for some of that to go down the drip tray drain. That will keep the drip tray running smooth as well too. And then the last thing we need to do is flush with water. Okay, I want to get as cold a water as I can to be able to do that. I want to make sure all my chemical, if I'm reusing the same sink or bucket, that has been rinsed out, and now all that chemical needs to get out of there. And I want to verify that cold water with pH paper once it matches tap water, somewhere in the area of about 7 on a pH scale is water. Okay, so we want to make sure that we do that. Once we get that done, we're going to remove every connection that we made to be able to do that, and reinstall the faucets that I've cleaned. Keg couplers, if they need a little TLC, this is a great time to do that. Wipe down the lines in the cooler, and any mold or mildew, if there was beer baths taken in between cleanings, that's a great time to just wipe those down and keep after that stuff as well. Well, I'm going to literally connect the couplers back to the beer kegs, and then the beer is simply going to push the water out to be able to do that. So basically that's what we want to be able to do. So hopefully when we open these places up, I know these are some scary looking pictures here, but hopefully if this is what we find, we need to do some heavy duty cleaning to get this back in order. But ideally, hopefully this will be it. Somebody will want a great looking pint of beer here to be able to do that. I know it's been a long time since I've had one, so I'm ready for one as well too. I hope you guys are as well too. So that's the end of what we got for you today. If anybody has any questions, we'd love to try to answer those now.
Dave, thanks a lot for all that great information. We do have several questions here. So first one is, what would have been the best alternative to leave the beer in the lines if you had to shut down for 2+ months?
Well, we recommended doing that, leaving the glycol, leaving the refrigeration as is to be able to do that. Now again, if that's the case, we definitely need to get back in there and see what the state of things there are. Again, the gas, do I have fresh beer to be able to do that? But obviously all of that beer is not going to be any good. So it has to get out and clean, and you may even have to clean twice if we're getting a lot of debris out when we do our cleaning process.
Great. Another question from, if an account opts to open up with their draft system halfway and the lines and system was shut down and the power pack was raised to 40 degrees with residual water left in the lines, when setting the power pack back to normal operating temperatures, should we just fill the lines that wouldn't be used with the cheapest beer on hand?
Yes, that's what I would suggest. We don't like having empty lines. When we have multiple beer lines in a glycol bundle, I'm assuming some of those lines depend on the other lines to be full of cold beer to keep them all cold. So yes, highly recommend filling the lines that you're not using. Obviously, we got to get that water out because that would freeze once we put that glycol back down to the proper temperature. We don't want that, but I would absolutely fill them with you know, the least expensive beer or any older beer that you have. But obviously we know that, you know, when we do get fresh kegs, that would have to go down the drain as well.
Awesome. Do you recommend dedicating specific lines to sour beer that utilize lacto, pedio, acidic, etc.? Or is there a cleaning regimen that would properly clean beer lines that previously had these types of beer in them?
So that's a good question. We get that a fair amount, obviously, as the sours keep getting more popular and popular. I don't know what's wrong with you people, but with the current barrier tubing that's very common in the draft world, you know, bar systems that are not 10 years old or older, possibly. The tubing today is better than it has been. The only thing, if we did have any vinyl that we talked about in the system on a short draw system or on the jumper lines, that certainly is going to pick up any flavor, whether it would be sour or fruit or anything like that. So generally, a lot of beer towers out there have stainless steel lines that, you know, once they're cleaned, they're really not a whole lot of flavor transfer on that too. You know, some of this stuff, the sours, I'm not a complete expert on sour beers myself, but you know, we haven't had many complaints before this, you know, on sours and rotating beers so often. Rotation nation that's going on out there, but just a proper cleaning process. Again, any vinyl in the system may have to be replaced if we picked up some off flavors and taste with that.
Okay, awesome. That's all the questions we have for you, Dave. Again, thanks for giving us this informative presentation here. To all the attendees, thank you very much for attending. Stay safe. Have a wonderful rest of your day. Thank you.
Thanks.